Hi, everybody. I'm Mike Lieberman. I'm co-founder of Kusari, a supply chain security startup. I'm also a TAC member of the OpenSSF. I'm also a governing board member of the OpenSSF and a maintainer of various open source projects, including Guac, and also do a lot of work with the CNCF and other LF groups as well. So I'm going to talk about the open source security sandwich. So before we kind of even get into what this open source security sandwich is, let's look at what the state of sort of, security data today, right? So we have the old world, right? We're moving to this new world. The old world looks like proprietary software composition analysis reports when it should be stuff like SBOMs, right? You have things like unstructured build logs and just sort of the data all over the place when you should have stuff like SLSA, which, and we'll go a little bit into which each of these things is in a second. We have exceptions to things like your vulnerabilities or whatever, or hey, I'm not actually impacted by this. That was often, somebody called you on the phone, somebody sent an email about a thing, somebody dropped a ticket in a thing, when it really should be structured in something like VEX. You have various proprietary health metrics, often dependent by organization, or you have vendors with sort of saying, hey, yes, based on our proprietary analysis, we say this is red, right? When it should be open, using things like scorecard. You have various custom security rule enforcement against, repos when you should be using stuff like All-Star, which once again, all of these are open. You have, repo service specific permissions, right? Like things like how, GitHub or GitLab might manage permissions when you should be looking at things like GitTough. The old world was, hey, if for anybody who's worked at a bank, you probably spent, or any sort of regulated institution, you've spent a whole lot of time managing things like control spreadsheets, as opposed to using sort of control frameworks and frameworks like S2C2F, OSCAL, and that sort of thing. You have also tight coupling of the SDLC system. So often when you're running your builds, you're running your publishing and all that sort of stuff, this was managed through things like, just I make an API call directly to the system as opposed to being more event-driven, allowing your system to sort of be asynchronous, allowing your system to be extensible, allowing sort of the events to trigger all sorts of other stuff down the line. And then, hey, all of this great data, used to be, every organization would have some sort of data lake that they would manage all of this stuff with, whereas they could use open source data stores like Guac to actually store all this to allow you to query this information. And so what does the security sandwich look like a little bit based on this? So at the top, we have things like, once again, SLSA, which is a build framework, OpenVEX, which is the Vulnerability Exploitability Exchange. It's a project underneath the OpenSSF. We have things like OpenSSF Scorecard, where there's a workshop also going on that today. We have things like All-Star. In the CNCF, we have tools like Witness, right? All of this on the top, these are all producer-focused, projects. So these are things like, hey, as part of me running an open source project, I am producing this data, right? So as a maintainer, I'm producing this data both for my benefit and eventually for the benefit of my end users. In the middle there, you have sort of, the inner bit of the sandwich, the tomato, the meat, whatever, where you have, how do we distribute this data? Right? How do we analyze this data? That's where tools like Guac come in. That's where tools like ArchiveVista or how a lot of this open source data flows into things like OSV, right, which is the open source vulnerability database. You have various things like also deps.dev where a lot of this data ends up in. And then on the bottom, right, the other end of the sandwich, you have the consumer side, right? So these are things like the SLSA verifier tools S2C2F, so for folks, because there was a question earlier in an earlier talk, what's really the relationship between SLSA and S2C2F, right? They're both on the different parts of the bread there, right? Where SLSA is heavily focused on the producer side, and S2C2F is focused on the consumer side. So, hey, what am I doing to actually safely consume this stuff? And safely consuming that stuff is going in, making sure that your maintainer, the projects that you are using, the maintainers are generating all this great data there. And then you have various other API tooling that can then, you could use to run queries, to better understand what your risk posture is, and all that great stuff. And then on the left-hand side is, hey, if the right-hand side is the sandwich, the left-hand side, which includes things like Intoto and Sigstore and Tough and GitTough, is the rules for actually making the sandwich. It's the, hey, there must be, this is the types of bread that we allow, this is where we allow this data to be stored, et cetera, this is what data needs to be produced, and all that. Cool. So now, great, what do we do with, this is a whole lot of stuff, right? And so now, whoops, let me just hit this again here. Right, so this is a whole lot of stuff. Maintainers want to do the right things, but they want it to be simple, and they want to understand the value, right? I've spoken to lots of maintainers across lots of open source projects, and one of the things they've said is, we're more than willing to do SBOM, we're more than willing to do SLSA, but we don't understand why. If you can tell us what is the actual value that we get and our end users get, then we're more than willing to kind of do this. One of the other problems, right, is tools don't always work well together, right? So we have a lot of problems today where, hey, this SBOM tool that gets generated is, this SBOM generator generates data that this other tool that ingests SBOM data doesn't really work well. The other thing, too, is tools work better with certain ecosystems than others, right? As we'll see in a second here. In the Go ecosystem, there's a ton of great tools, and they all kind of work pretty well together. In certain other ecosystems, especially legacy ecosystems, that's not the case, and in some more emerging ecosystems, there's still a lot more work to be done. And so, yeah, so maybe how can we solve some of this? And I'm about to show off here in a second a project that I created called, an open source project I created called Skootrs. And if anybody wants to follow along, more than willing to, feel free to run cargo install Skootrs bin, assuming you trust me, along with a GitHub token, and you can play along. All right. Okay, so what does Skootrs do? So I can create a project, or actually let me just show you what the commands are for a second. It has a bunch of stuff in here, but let's start simple. So I can do Skootrs project create, right? Give it a name of the project, give it a description, say where I want this thing to live. I'm gonna make sure it lives in just my personal account. Right now it only supports the Go language. It could potentially support more in the future, but let's see what this thing does, right? Kind of hard to sort of follow here exactly, but largely what this is doing is, in fact, actually, let me rerun this with, actually, hold on a second. This is maybe a little bit easier to read. So let's scroll up here. You can see, what is it doing? Oh, it's creating a GitHub repo. It's generating a CD event for that GitHub repo that, hey, I generated this repo. It's initializing a Go module. It's writing a README. It's generating a license. It's generating a security.md. It's generating a security insights file, which is yet another OpenSSF project. It's generating a releases.yaml. And doing all these different things. And if we go over to here, and if I, so you can see it created a project, right? And what are some interesting things about this project? Well, if I go to security and I look at the code scanning, right? Well, it ran scorecard, and I only have 4 things that are not, it doesn't pass, right? Whereas normally if you created a normal project, it'd have like 20 things that immediately don't pass. So by sort of generating all of this stuff, and I'll show what all that looks like in a second, by generating all of this stuff, we're able to show that, you know, yes, we've turned on dependency tracking, we've turned on, you know, vulnerability tracking and all of these things like SAS scanning and DAS scanning and all that great stuff. And the only things it can't do, right, is it can't magically create a second maintainer, right? There's only one of me and it just can't magically make a second one of me. The same thing goes with code review, because it can't magically create a code reviewer for me to enforce code review against the project. Fuzzing is something that requires a lot of actual resources, so that costs money, so there's a lot of manual effort to actually apply to some of these fuzzing projects. And then also the CII best practices badge is a manual application. So can't do that. But everything else, it passes, right? And this is the sort of thing that folks have been sort of saying is like, hey, if I have to look through a list of 20 or 30 things, that is a huge amount of work. But now that I have all of this, what was I going to say? Now that I have all of this set up, great, it's all in there. So the other things are, so if I go also over real quickly to just look at what the actual thing, actually, if I go over here and go and create a new release, one of the things I can do here is create a new release. And now it starts to actually run all the other things that we want as part of a good project. And I'll show what that looks like in a second. But first, let me show you what that sort of release looks like. So in this case, it's running Go Releaser, but it's running Go Releaser with a SLSA GitHub generator, with generating SBOMs via Trivy, and all of this great stuff automatically. So now, hey, if you don't care about what particular tool you want to use, you could just kind of use this, and it'll generate all the things for you, yeah. And just to show, now to kind of go back here, now since that's going to take a while to run, I already did sort of the cooking show thing, where where if I want to now go and pull down some of this data to then do stuff with, right, I can go and pull in stuff like, let's just say, you know, here I can go pull in, you know, in this case, let's say the SBOM, right? Not going to be a whole lot of interesting stuff in this SBOM because it's just like a hello world app. But here, boom, I have this SBOM, and I also have a label associating it with the S2C2F requirement AUD4, which pretty much says, hey, verify the SBOMs that you have. So now we have this sort of connection between all the different pieces of what we're doing within OpenSSF. In addition to that, we also have, I can also pull in the, real quickly here, I can pull in the SLSA attestation for this project. Right now it's all base64 encoded and yada yada, so I'm not going to go too deep in there. But imagine, you know, I've already pulled it down, right? And I have this multiple in toto.jsonl, and if I just pull down the command there, right? I now verify it against this, and you can see, hey, it passed, right? And all of this is sort of just sort of baked into the default, the safe default, which is what a lot of projects are asking for, right? They're saying, hey, we don't want you to make our current workflows any harder. We don't want you to blah, blah, blah. But we don't necessarily care what tools are used to generate the SBOM, what tools are used to do all that sort of stuff. So now, to go back to the presentation here, real quickly. Okay, so what did we do? We generated a highly opinionated configuration for security, right? We output everything we did as events, including CD events, right? So now you have this ability to say, hey, I actually am tracking what security things were done against my project. we store the state of what we did inside, in this case, inside the repo, but there's a couple other options we are looking at, and since we store the state of what we did inside the repo, obviously right now that's not particularly secure, but as we look at it, this sort of thing in the future and look at integrating stuff like All-Star and GitTough into the process, we can start to essentially enforce that this security state that's located inside the repo can only be changed by Skootrs or an approved like security actor. We pulled, security-related project release outputs, right? So we're also showing not just, hey, we're not just generating SBOMs and SLSA attestations for our health, right? We're generating them because they actually have a use, right? They can be used to sort of verify that, hey, this build actually came from the right repo, and this artifact that I had downloaded, right, represents actually that SLSA build, and so on. And, all of this sort of coming together into something that looks like a kubectl-like functionality for managing project security, right? And I didn't show off a bunch of other things in there as well, but there is an experimental REST API. So if you don't want to run this purely as a CLI, but you want to run this as a service and then have things connect to that service via API tokens or whatever, you could do that as well. You could also idempotently sort of update existing projects as long as it's within the same API schema, which, given that this is very early on, it'll probably change a lot, so don't trust it too much for that. But yeah, and so where do we go from here, right? So there's this movement towards an SDLC or supply chain control plane where all of this data, right, that's going back and forth, right, it needs to be looking like stuff like in toto attestations. And so that we can kind of communicate all this information about what is happening to our projects, what is happening to our supply chains in a trustworthy way, right? And so follow modern approaches to application security. So we should be doing stuff like zero trust. We should be applying identities to our software, to our code, and that sort of stuff. It should be event-driven, right? Don't make these things synchronous because we're just going to cause lots of issues, and then apply policy as code. And if folks want to see a talk on this, I know, don't worry, the slides are all uploaded to GitHub, and so you can find the link in there as well, and they'll be uploaded to SCED. But if you want to see something that shows how we actually take that data and pull it all down, you can kind of follow that, pull it all down and then run policy against it. You can follow that. And then, at the end of the day, we need to bring in more end users and maintainers into the conversation. And finally, so join us. So once again, looking for more contributors, looking for maintainers. It's v0.1 is out right now. Here is the QR code if you want to join the community. If you want to follow along, skootrs.sh, or github.com/kusaridev/skootrs, and then, yeah, feel free to come join. We have a lot of good first issues, including, for example, this link right here is not in the README. Maybe it should be in the README. So, and that's it for me.